Hello and welcome back to another lecture from Organic Chemistry. If you are using any reducing agent like sodium borhydrate or lithium aluminum hydrate, because you're going to add H minus to a carbonyl group, that's not going to change order of the carbon that used to have the carbonyl. What does it mean? That means that whatever you start with, you will, it will have the same order. If you start with aldehyde, because it's a primary, it will give you primary alcohol. And if you start with a ketone, and the ketone is a carbon that it is attached to two more, or like a substituent, or two more carbons, the alcohol that you will get, it will remain secondary. Okay. What will happen if I use a nucleophile that is bringing carbon with it? And one example is going to be the Grignard reagent. We know Grignard reagent and can bring, like an alkyl or aryl group with them. So that means that we can change length of the, the molecule by adding new sigma bonds to it. Now, it depends on what you start with. Order of the alcohol that you will get, it will be different. If you start with if you start with aldehyde, it will give you a secondary alcohol. And if you start with a ketone, you're going to get a tertiary alcohol. Okay, let's practice some example about them. And so I do have a carbonyl group, and the carbonyl in this case is aldehyde. I'm adding a Grignard reagent to it. Anytime you see a metal attached to non-metal, just simply put a negative sign top of the non-metal and a plus sign top of the metal. So your nucleophile, it will be the CH3 minus 1. And this nucleophile, it can attack the carbonyl from the top of the molecule or the bottom. What does it mean? It means that there is a chance to get chiral centers. And the intermediate you will get, it will be something like this. So you have a carbonyl, that carbonyl, okay, it will have oxygen with 3 lone pairs. We add a CH3 to it, and here you go, CH3, and we do have hydrogen there attached to it. Now, this one, it has -1 charge. Very soon, it will get a CDKH from, for example, the solvent, or I can say it will go after this. And it will take the positive H from water. And that's going to give us such a molecule. We got carbon with OH, and other side, we're going to have CH3. And remember, we do have hydrogen. So our alcohol, it will be a secondary alcohol. We started from aldehyde, and we ended with a secondary alcohol. Okay, now let's look at the number of carbons. Used to have 2, 3, 4 carbons. But right now we have 1, 2, 3, 4, 5 carbons. So Grignard reagent will add a new carbon-carbon bond. And now this carbon is going to be a chiral center because it has 4 different substituents. And so I'm going to say I have a carbon that attached to a propyl group. I have CH3, and I can have OH facing to us and hydrogen back of the molecule. In that case, this one, it will be S configuration, or I can have hydrogen facing to us, and the OH, we can send it back of the molecule. In this case, I say 1, 2, 3, and this one is the 4th. It's supposed to be S, but because the 4th position is facing to us, we will flip it, and it will be our configuration. So I got enantiomers. Right. We got enantiomers. Let's practice a ketone instead of aldehyde and see what will happen. So until now, we know if we start with aldehyde, not only we add new carbon-carbon bond and a new sigma bonds, we will get a secondary alcohol. And the reason for it was because of this H. Now, any ketone will have a carbonyl group that attached to two carbons. So this carbon is already a secondary. If you add any new carbon to it, that's going to increase order of the carbon. And the first step of this reaction, you have an aryl halide that will react with magnesium, and while the solvent is THF, or you can say is a type of an ether molecule. And because it's a dry molecule, a dry solvent, it will give you such a reagent. Just simply put Mg between Br and the ring. So I'm going to put Mg here. Now I will attach the Br to it. This one, it will be a plus. Okay. And so that means this ring is going to have a negative charge. Now, this one, it will be my nucleophile. And it will attack any carbon group, whether it's aldehyde or a ketone. So next step, we're going to have such a chemical reaction. Our nucleophile, the ring, it will technically attack this carbon. And if that one happen, let me rearrange it a bit. I'm going to put the ring somewhere here, and that one, it will be CH3. So I have CH3 here, and the ring is there. And what will happen with the carbonyl, it will show up as oxygen, and oxygen, it will have a negative charge. Very soon, it will get positive. It will get H plus from any acidic, like technically center, or like if you have a solvent that it has acidic H, it will take H from it. So this one is going to go after it, and it will turn to this molecule. So the final step, we will have H attached to oxygen. Okay, now my molecule had stereocenter before, and this one was the stereocenter. And the configuration for it, I can say this one is number 1. That's going to be number 2. This one will be number 3. And what's the fourth one? The fourth one, we have hydrogen facing to us. And that's going to be the fourth priority. So I have 1, 2, 3, that's supposed to be R configuration, but because hydrogen is facing to us, the fourth priority, we will flip it. It will be S configuration. So we have S configuration there. Now, we got a new chiral center, and that's going to be the new chiral center. The new chiral center, it can be R or S. So I will get these two molecules. I'm going to redraw it. So I can have OH facing to us or back of the molecule. So in one case, we can draw OH facing to us. That means we need to have one group back of the molecule. So let's say methyl is back of the molecule. And this is OH. In another case, we're going to send methyl back of the molecule. Give him. Sorry, we're going to send the OH back of the molecule, but the methyl, it will be facing to us. So the methyl is facing to us. All the OH, it will be back of the molecule. Let's assign the configuration. Remember, we had S here, and now what do we get here? We get 1, this one will be 2, and that's 3. This one, it will be R configuration. And the next one is going to be S configuration. We have 1, this one, it will be 2, and this one will be 3. It's supposed to be R, but because the methyl is fourth priority and facing to us, we will flip it. So this one will be S. So what did we get? We got S and R, and this one turned to S and S. Only one chiral center got flipped. And in that case, we say we are dealing with diastereomer. Okay. And diastereomer, okay. Diastereomers. So if there is a chiral center inside the molecule, and you add a Grignard reagent or anything, and that's going to create a new chiral center, in that case, we say you will be dealing with two products, and the relationship between them, it will be diastereomer. They are not going to be enantiomer. They will be diastereomer. And because one of the center is not going to flip under any condition, stay as it is. The S is not going to, nothing is going to happen to it. Which S? I'm talking about this chiral center. That chiral center is not involved in any chemical reaction. And so that's the reason we say you are going to get diastereomers, not enantiomers. Okay, another example. In this case, we have alcohol, and our alcohol is a primary. Next thing is we have only 2 carbons attached to the alcohol. We want to turn it to an alcohol that the chain, now it has, the parent chain, it has 4 carbon, and instead of 2 carbons, we have 4 carbons, and so we increase the parent chain, or we increase the backbone technically, and we have a secondary alcohol. So it used to be primary, now we have a secondary alcohol. Okay, and let's see how we can move to that direction. I know if I take aldehyde and reduce it, that's going to give me a primary, secondary alcohol. How? I need to use a Grignard reagent or MgX. If I use any Grignard reagent, it's going to give me a secondary alcohol. Well, ketone, if we add R mgx to it, it will give us a tertiary alcohol. So we started with a primary alcohol and we ended with a saccharide. Okay, so one way is to take the alcohol, turn it to a carbonyl, and then reduce it to saccharide alcohol. How can I, do that chemical reaction? First thing is like it says OH turned to bromide. I need to replace OH by something. OH is not a good leaving group, but I know Br is a good leaving group. And so in order to replace OH by Br, we can use this, PBr3, and the solvent, we can use pyridine. Okay, and this is structure of pyridine. Listen. Benzene technically ring that it has nitrogen instead of one of the carbon atom, and nitrogen it has a lone pair. Okay, next step, Br got replaced by Mg. So you need to use Mg, and the solvent must be dry. I can use ether, or I can use a THF as a solvent. THF also is an ether molecule. And next step, now this one, it will be added. Okay, it will be added to whatever you have. Now I have only 2 carbons. I need to add it to something that not only is going to increase number of carbon atoms, also it will give me alcohol that is a primary is a saccharide. Okay, I have 2 carbon and I need to turn it to 4 carbons. So I need to use a backbone, something that it has only 2 carbon, because I'm going to add 2 carbon to it. And next, because I need to get the saccharide alcohol, it has to be aldehyde. It has to be aldehyde. Otherwise, it will give you give you a tertiary alcohol. So next reagent is going to be this. This is going to be my next reagent. Take this one, and I'm going to add it as a reagent. So this is my next reagent. So now I will have such a reaction. Let me erase this one. I have MgBr is going to react with ethanol. This carbon with a negative charge is going to go after the carbonyl, and it will give me CH3. C. Now I get OH. We add H plus also to the solution. Okay, this one is going to happen next step. So we get here CH2, CH3. Okay, that's the same backbone. Okay, now I have oxygen with a negative charge. Next step, I will add H plus to it, and that's going to give me this molecule. And this is the way we run the chemical reaction. And I'm going to keep this one for next lecture. And we have a cyanide that it can behave as a nucleophile. And the nice thing with the cyanide, it will open a new window for you to get new functional groups. But for now, thank you very much for watching this lecture video.